Thank you very much, Thomas, for your invitation, everybody. I hope I will be able to explain a little bit more what I'm doing in combination with our group. Could you just double check with me if the slides will... here we go. Right. Okay, yeah, thank you. So the Max AI. So the Max is actually the name of the product line. It's not per se the robot as we have been launching. And the AI stands for artificial intelligence. So we are belonging to the mother group of BHS, which is a bulk handling systems, and actually comes from the same state as Digimarc. And we are very happy to be part of that group. This is a group that have been working in the recycling industry for over 35 years. And as a BHS have been a producer of the so-called screening technology, which is applicable in a lot of material recovery facilities. In that same group, we have also Nihat, which is a producer of the air technology based out of Amsterdam, Holland. And then we have NRT. NRT is the optical producer based out of Nashville, Tennessee. And we are, as Max, we have a division within the NRT. So the Max has been promoted from April 2017, and we have our very first robot in action since April 2017, and has been working ever since. To come back a little bit about the need for interactivity of the whole supply chain. We are talking about a major issue here that requires a lot of attention, not only from the producers like us, but actually comes down to the need of the understanding of the concept of waste and how does it all trickle back to the need of recycling and making sure that we are making the world a little bit of a greener place, right? And I think that Digimarc has a very strong solution, and I really applaud that process, and I hope it will succeed in the years to come. However, we have nowadays a lot of recovery facilities that are now using a lot of manpower and manual picking. And this is why we have also been looking into reducing that. And so this has been the philosophy and the vision of our company to make sure that we have a solution that is now in place that can actually reduce human errors and human interactivity with the waste. Of course, lowering the operating costs as well. More meaningful data, because we are using AI in combination with the camera system and, of course, a database that can be linked actually to the internet. But more to come on that. And, of course, the need for recovery and purity is, of course, ever stronger, especially now that our Chinese brothers are closing down. But, of course, they do that with a very clear, distinct reason. And this is also, of course, triggering us as a total company and also the industry to make sure that we do something about it rather than just to leave it on the side. So the external factors why we have been able to develop this Max AI technology is because of the developments actually on the AI. AI exists for many, many years, but now we have seen that specifically with the use of deep learning and AI in combination with robotics, we have seen that it is actually a solution that we are able to plant into the market as we speak. External costs, of course, labor costs, being able to be making sure that the OPEX reduces as much as you can. And also what the problem nowadays is that we see that also not only in the Western Europe world, but we see that all over actually is that the labor scarcity is an issue. A lot of people are becoming more aware that this is not a career path for them to be following. And of course, then also, of course, the increasing quality requirements by the actual recyclers of the commodities. So to come back, I think on the earlier discussion with Carlos on the table, nowadays today it is really we have a MRF facility, but actually it's a black box. And we do not really understand also from the outside what is happening in that black box. And so we try to be sure that we try to solve that black box. And but nowadays it's always a system of compromise. The real essence of automation by applying robotics and being sure that the robot is able to pick as good as a human being can do, right? This is our expectation of the introduction of the Max AI, to replace the human labor. Right? But it is not only a matter of cost, it's a matter of injuries, right? Supervision is involved. You need to be training all of your staff and maybe on a weekly basis, because somebody doesn't return on the Monday morning, and then you have an issue. You have to be sure that he's getting again the same training for another type of job. Breaks, of course, yeah, everybody needs to have some time off after certain hours. Of course, overtime work, labor pay, but there certainly is absenteeism. I've been talking to a customer that has been working on a MER facility, and in that same year he was replacing on one specific position 83 different persons in 1 year. 83. So for him this was, you know, a no-brainer in that sense. So to be making it a little bit more easier in that sense. But it is not only the sorting bit that is of course interesting, but it is definitely also the data. The data collection that you can retrieve from the Max AI. But to come back on the technology itself, so the Max AI as a robot actually is actually more or less acting as a human being. So we are looking down at the material through a camera system, simple camera system, not specifically in NIR, but we are looking down at the camera, and then we have created a brain, which is of course the neural network, as we say, and that is containing all the data that is required for the Max AI to perform at certain duties. And then we have the ABB robot, which is the mechanical part and actually replaces the hands of the manual sorter. So it is actually can see, it can think, and can act, making decisions and driving the results more or less as been instructed by a human being. So this is now our latest product line portfolio. So we have developed through our NRT optical technology. We have now tried to make a more standardized product line, and we have added a few other components. So we have now on the top right, if we see. So on the top right is actually our optical sorter in combination with the artificial intelligence brain, as we can say. I have a video to come back to that later. On the right bottom side, we have the Max AI AQC2, which is actually a double-headed robot. So that is more for voluminous material. I have another video for that as well, with the paper and cardboard sorting. And then we have the traditional first product. This is the AQC1, and that's a one-headed robot. However, now since the early May, we have also launched the Cobot, which is a collaborative robot, also produced by ABB. And that is possible to have it linked with 4 into one brain. So we are focusing on reducing or replacing the manual labor in today's situation, right? So definitely we are not the solution, but we are part of the solution, and being sure that we can drive better results in the very near future. And then we have also a separate visionary system. We call it the VIS, and this is an analyzer, an online analyzer that is capable of looking down and collecting data from the conveyor belts. So and then it can make a material composition in real time. This is just a slide. So we have installed now the very first Cobot at the US plant, and it's on a quality control. So we have been looking down at, of course, the experience. For your information, we have already more than 60 of these robots in operation worldwide. So we have installations running now in Australia, in France, even in France, Belgium, of course, the US, China even is now moving into that robotic situation as well. So although we have been quite young in our, let's say, working field, but we do have already gained a lot of experience by having the robots in the field and collecting the data that we need to improve ourselves. Okay, the latest development that we have pursued is indeed the combination of the traditional NIR and the AI, right? So we have combined the two, and that is a visionary system, as is this used with a robot. It's now being applied into the optical sorter as well. So it is looking down at the same speed as an optical sorter. This example here, actually this customer was using the NIR already for paper recovery, or fiber recovery actually. But it was found that also canet, so the metal cans were wrapped with paper. So the NIR was only able to detect the paper, of course, and it was shooting along the metal cans with paper wrapping. But then we added the MaxAI visionary system, and we told it, hey, listen, you need to be looking down at the object as well. And then it's actually able to suppress the signal to the NIR so that the metal can is not being ejected along with the other fiber, which is the commodity. So that was the interesting development. But it is not only for that reason, of course, but you can imagine that in the world of PET trays in combination with PET bottles, right? It works the same way. Also in the paper cardboard sorting, when you need to remove pizza boxes or let's say inked material, we are able to actually tell the MaxAI visionary system to look at it as a human being can do, and then for helping the NIR do a better job. Okay, this is actually going to be it. So we are actually going to be, and like I mentioned, able to characterize the input based on our visionary systems to have a look at the material stream and to see how it is comprised, to be sure what is coming in, and being able also to make a product by design by using the AI technology. Thank you very much.
Merci.
So actually we are looking down as a human being, right? So we have a certain weight limitation in order combination also with the speed. So we prefer to have material to be picked up from a 50 millimeter to about 350 millimeter. This is the average, but in reality, of course, waste streams are not that specific size. So if I understand correctly, it is about the...
How many tons per hour can you...
Okay, so we actually do not talk about tonnage. We have a limitation on picks per minute. So that amount picks per minute is the movement. Okay, thank you. It's the movement that is related to the weight of the object. So you can press down, let's say, for example, 10 tons per hour, but the limitation is 70 picks per minute. So even if you're in your 10 tons per hour of paper, you have 100 objects of contaminants per minute, that requires then actually a doubling of the robot activity, meaning another robot needs to be added, because the limitation is the amount of picks per minute. That is actually related to the capacity stream that is required to do so. So we have a variety of width. And so in any optical sorter, you have a variety of width related to the capacity and the objective for the sort. And so we don't have a limitation on the amount of picks, or let's say amount of capacity per ton. It depends really on what is your objective. So if you have 10 tons per hour of paper cardboard, perhaps we require then 3 different systems to do 3 tons per hour. It really depends on the situation itself. We adapt, let's say, the MaxAI robot to any customer-specific waste stream. This requires actually to be having a so-called mobile recording unit installed prior to the delivery of the robot. So we need to make understanding of the waste stream, and we need to develop the neural network that is created, and then for instruct actually the robotic tool as such. That's the way. So we use a device, a kind of process before we actually are able to launch the robot in the field. So it requires in-depth learning that is going to be able to adapt itself to the waste stream of the customer.
So I guess that you have a video of the stream and that you learn which one is a PET bottle, which one is
yes.
okay.
We developed, of course, the database in the very beginning that was containing a few 100,000 of pictures, and nowadays we have 60 of them in the field, and we talk about hundreds of millions of pictures already, because the first robot has been working already for 2 years, and we are, let's say, increasing that number quite rapidly. So all of those images we can use, of course, in order for the database to be created better. We are able to do that. It requires a lot of software engineering, to be honest, yes, but it is possible. The AI shows that it is possible to identify a specific brand of a bottle. So we actually do that already at a certain customer that had a requirement to be very specific in terms of identifying the Evian bottle, right? So that is actually possible, but requires more in-depth software construction. We have, like I mentioned, created a database that is now consisting of millions and millions of images. And the images are, like you say, crushed, shredded, non-shredded, folded, smudged, filled with material inside, etc., etc., etc. So all of these specifics and uniqueness of the product are able to be adapted by the AI. So the AI can learn, and of course a deep learning aspect can then recognize and create a kind of confidence level that it is making sure to make that separation. We are a manufacturer of the sorting robot. We are not a collector of data. We use the data solely for the development and improvement of the Max technology, full stop, in combination of the ideas and wishes of the customer. Right, so we have, of course, images. The images remain the property of the customer. We are not, let's say, doing anything with that. However, the images linked with the so-called AI data around it, this is actually our data. This is our property. This is the reason why we are able to identify specific bottles in a waste stream that is not recognizable by humans. This is the difference. Well, we have several videos. So this is actually the Cobot video that has been launched. So ABB is the producer of the robot, but the technology is still the same as the previous one. However, this is a robot that we have developed for very small spaces and areas. That is not, let's say, having a lot of retrofit possibilities, and this makes this a little bit more easier. This specific robot actually is being used in the medical preparation industry a lot, and we have now adapted it to the waste industry. So the visualization of the waste and characterization of the waste is done, of course, by the Max AI, and the robot is just a tool. But it's using vacuum, overpressure, under pressure at the same time. The reason why it has a red jacket at the moment here is because it has a lot of joints, and these joints are not IP65, but they need to be covered for dust and humidity. So it's And when it is close by to a human, it has a lot of sensors in it, and therefore stopping, for example. So this person here touches his right arm, so it's stopping, but at the same time his left arm is still continuing. And this is the meaning of collaborative robot. All these videos are also visible on YouTube. We are not showing anything secret, so you can have it available on YouTube as well. So this video was actually recorded at a facility, as you could have seen, at a customer that is treating a lot of plastic waste. So at this moment, this was a first video and the first installation. And we needed to, of course, make sure to adapt it. But we have done thorough testing on the robot being able to grasp the objects that is being needed. If it still has the Evian, let's say, ticket or the label around it, yes, we can still detect it. But if the objective is that because the Evian changes the PET to another polymer, and that is now a contaminant, it requires, of course, a new adaptation of the neural network. Yes, so we are able to adapt it, but it needs to be very specific.
Ok, merci.